All right. Well, thank you very much for joining us. My name is Travis Clayton. I am the National Sales Manager for KWUSA. KWUSA is one of the three major brands that's part of RM Manifold Group. RM Manifold Group is who I work for. We're based in Fort Worth, Texas, and KWUSA is a partnership with a German company, Kutzner and Weber. They are very well established. They've been over there in Europe for about 80 years now, but they've only been in Texas for about, or in the U.S. for about 2 years now, a couple years now, and we've kind of modified some of their products and listened to them to U.S. standards so that they are a better fit for the U.S. market. And so today I'm going to talk a little bit about proper fireplace venting. The science of smoke. If you do have any questions, there is a little question box down below. You can feel free to submit your questions there. So first, we'll talk a little bit about natural draft, natural venting. Then we'll talk about how to solve a lot of those common draft problems. We'll touch on some relevant codes for both gas-fired and solid fuel fireplaces. Then we'll talk about mechanical drafts, some of the advantages of using draft inducers and barometric dampers. And then lastly, we'll touch a little bit on EPA Step 2, which is kind of a new recent change to the industry. So natural venting is the most popular and economical way to vent a fire. It's also known as gravity venting. Natural venting, it uses the difference in density of cold versus warm air to create draft for the fireplace or the appliance. Essentially, warm air rises because it has a lower density than cold air. So wouldn't it be nice if fireplaces had perfect draft every single day of the year, naturally, just like in this picture? But we know that's not always the case. Natural vented fires, they're very sensitive to a number of different factors, which can cause natural vented systems to not always function as expected. So a well-designed and well-functioning venting system is actually more important for a successful fire than a good fireplace or a good stove. So kind of draft problems, they do kind of fall into two categories, underdrafting and overdrafting. So underdrafting happens when you don't have adequate intake of velocity in order to capture all the gases generated by the combustion of that fire. So it leads to smoke in the house. It leads to carbon monoxide in the house. It's very dangerous. And this is actually against code. By code, you do have to exhaust all the products of combustion to the outside. So hopefully I don't have to explain this is very bad. When actually kind of a situation happened to me a couple of weeks ago, I had thrown a couple of papers in the fireplace to burn them because they had personal information on them, and it was 100 degrees outside. And because the pressure differential, all the smoke came into my house, and luckily it was just a few papers, but it was bad. And then, of course, we have overdrafting. So overdrafting, when you're overdrafting, you're pulling a lot of conditioned air out of the room. You don't have a complete combustion of your fuel. It's very, very, very inefficient, and you're not heating your room properly because you're drawing all that conditioned air and all the heat out of your room too. So it becomes very expensive, and it also leads to higher emissions as well. So for one of the first issues that affects your draft is going to be chimney height. In general, rule of thumb, a shorter chimney, you're going to have less draft, and a taller chimney, you're going to have more draft. So tall chimneys, they're very common in multifamily or multi-story apartments with fireplaces, hotels with a big fireplace in the lobby, or also you see in this picture, you can have issues because a large portion of the chimney is exposed to the outside. So in general, yes, a taller chimney does equal more draft, but only to a certain point. At a certain point, additional height, it gives the flue gases more time to transfer heat into the chimney and cool off, and it actually reduces draft. A good rule of thumb is to have a chimney height no less than 15 feet from the top of the appliance, but there's also a lot of other considerations we'll talk about. Terminations is as well. When they're too short, it's actually against code because terminations, they have to be 3 feet above anything within 10 feet of the chimney by code. So if it's too short, you can extend the height of the chimney, or you can install a mechanical draft system like a draft inducer. If it's too tall, you can attempt to reduce the height of the chimney, which is expensive. You can attempt to insulate the chimney if you can, or to decrease draft, you can use a barometric damper to reduce overdrafting, which is often the easiest, cheapest solution. And I'll talk a little bit more about that in a few slides. So another issue we run into is when the chimney is outside the building envelope. The chimney, it tends to stay cool because it's exposed to the outside air, and this is really dangerous, especially during startup, because that temperature of the chimney is almost the exact same temperature as the outside. So you have virtually no draft during startup. So you really need a draft inducer. On this one, this chimney here, there's one of our little RSD draft inducers up top. So a couple solutions here. You can either attempt to re-insulate the chimney, which will help, but it might not fix the problem, or you can install a mechanical draft system to completely solve the problem. So another issue we have is flue size. So the larger the flue size, the more capacity of that flue. It's kind of like blowing through a coffee straw versus blowing through one of those shake straws. You're going to be able to blow a lot more air through a larger straw. So, and this is typically sized according to flow requirements and opening size. So sometimes you have draft problems when you have insufficient flue sizes, like if you have a one-sided fireplace that's been converted to a see-through fireplace, or if the chimney is relined and it decreases the diameter. Or also happens if like you have a smaller appliance like a stove that's connected to a larger existing masonry chimney. And it can also happen when you convert a wood burning fireplace to a gas fireplace. So when you run into this issue, you can either rebuild the chimney or fireplace, which is expensive. You can decrease that chimney size, or you can also reduce the opening size. You can install like a glass or insert, or you can also install a mechanical draft system. So flue sizes typically sized in relation to fireplace opening size. Opening area. So if the opening area is too large, the fireplace will not draft properly. It doesn't create enough velocity to safely evacuate and vent all those flue gases from the room. So traditionally, hundreds of years ago, they in these castles in Scotland, like you see in this first picture, they built these huge fireplaces, beautiful fireplaces, but big enough that you could practically walk into. And a lot of times they didn't draft properly, and they didn't know this. So as you can see in this picture, they actually installed a little insert in there to kind of reduce the size of that opening and flue, so it does draft properly. So you also it's also very common with see-through fireplaces. If you don't have, if it's not a closed-in fireplace, you can have turbulence between the rooms, which can cause a lot of draft problems too. So a lot of times with these see-through fireplaces, they are enclosed, like you see in this second picture here. And these pier fireplaces, they're like that. If this was open with that amount of surface area, there's no way that would be able to properly vent without a mechanical draft system. So we do install a lot of mechanical draft systems on these manufactured fireplaces like these pier and see-through fireplaces. So open systems like the first and the third picture, they require much larger chimney capacity to be able to exhaust a large volume of gases. They also allow more excess air to be introduced, drawing more room air, lowering the flue gas temperature, thus reducing the draft. So closed systems like stoves and fireplaces with doors, inserts, some ovens, they burn more slowly, and they need less dilution air because there's less flue gas volume at a higher temperature. So sometimes you also need more draft with it with the closed systems as well. And then of course sometimes you have a modern architecture. Yeah, let's just put the fireplace right in the middle there, which is beautiful. It's a beautiful fireplace, but there is no way with that amount of opening area that fireplace is going to draft properly and vent all those flue gases out of that room without a mechanical draft system. So a lot of these manufactured fireplaces, they require mechanical draft systems. They're becoming more and more common. So of course, you always need to see the manufacturer's recommendation, installation instructions for these mechanically vented fires. So when you have these open systems, really your solutions are you can attempt to reduce the size of the opening, closing it in, adding a glass or an insert, or you can install a mechanical draft system. A lot of times the most easiest and effective solution. And then you have all these variable effects. As we know, draft is not constant. It's constantly changing based on many factors. So first off, the wind. If it's windy outside, it can create a lot of turbulence around your chimney and create downdraft down the chimney. It could blow smoke in your house. You have the outdoor temperature differential. If this is what happened to me a couple of weeks ago. If the colder it is outside, the more draft you're going to have. The warmer it is outside, you might have an inversion if it's colder in your house. So outdoor barometric pressure. So the higher the barometric pressure, the more draft you're going to have. The lower the barometric pressure, less draft. Temperature combustion. What are you burning? Wood, gas, coal? What type of wood are you burning? What stage are you at in the fire? Is the fire dwindling down, or is it just starting up, or is it roaring? How's it going? And it all affects the draft. Volume of fuel. How much wood are you burning? Is this a bonfire, or is this just a tiny little fire? Are you cranking the gas all the way up, or just kind of keeping it low? Temperature of the flue. The hotter that flue is, the more draft you're going to have. So when you first start up a fire, that chimney's cold, and you're not going to have as much draft as once that chimney gets primed and gets warm. And then you have obstructions you have to consider. You could have soot or creosote, a bird nest. There could be deteriorated chimney liners and restrictive caps. All these things increase the flow resistance and decrease draft. So how do you possibly take into considerations all these changing factors when you're designing a fireplace? Well, actually, that's not all. There's more you have to consider. You have design considerations. What type of chimney? Is it prefabricated or masonry? These different types of chimney. How well is it insulated? Is it single wall, double wall? All these fireplaces, different chimneys are going to absorb heat at different rates. What type of surface is the interior? Is it a smooth surface? Is it corrugated spiral? Is it masonry? A rough corrugated or spiral surface is going to have a lot more flow resistance than a smooth surface, and it's going to decrease your draft. And it's the same with elbows. If you have elbows in your system and it's not a straight up chimney, you're going to have more flow resistance, and it's going to reduce draft. The damper size is the damper size properly? Small dampers, they can create bottlenecks and more flow resistance. Or the lintel or the hood, which is the little top part of the opening of the fireplace that comes down to capture all the smoke. If that's not sized properly, if it's too small, smoke can roll out and come out into the room. Same with the smoke chamber. Code gives us recommendations on how these smoke chambers should be designed for natural venting. You should have no more than a 45-degree angle, and the height of that smoke chamber should be less than the width of that opening. But a lot of these modern fireplaces today, they don't have smoke chambers. It's almost just a box, or the smoke chamber is very small, so they have to be installed with a mechanical draft system in order to vent properly. And we also have some building considerations. So if you're living in this blue house and you're surrounded by tall buildings and trees, you can have turbulence around your chimney, you can have downdraft, you can have all kinds of draft problems, or if your building is too tight, you're not going to have sufficient air for combustion. So fire needs air to combust. If the building's too tight, and combustion air can't be supplied to that fire, the room will go into a negative pressure. Smoke will start to spill out in the room. And if you notice, if you open a door or a window and it solves the problem, your fireplace starts smoking, then you probably need to provide an outside air supply. And this can also, negative pressures can also be caused in your room if you have another mechanical ventilation system like a dryer that's also exhausting air, pulling air from the inside and exhausting it outside. That can also cause negative pressures in your room. And then you have stack effect, which stack effect is very common in multi-story buildings. So basically, elevators, doorways, exhaust shafts, and stairwells, they cause the building to act like a chimney and draw air through the building. In the winter, when that air comes into the building, it's heated up by the building air conditioning system, and so it naturally rises and exits through the top of the building. Opposite effect happens in the summer. When air enters the building, it's cooled down by the building, and so it falls and it comes out the bottom of the building. So open fired systems, they often experience draft problems due to stack effect because the chimney draft is eliminated due to negative pressure at the inlet of the heating appliance, which causes spillage into the room. So a lot of times installing a mechanical draft system is the simplest, most effective, and least expensive option to fix a lot of these problems. So now for the exciting part of the presentation, code. So NFPA 54, also known as the National Fuel Gas Code, primarily deals with your gas-fired appliances, while NFPA 211 primarily deals with your solid fuel burning appliances. But if you want some real exciting reading, you should definitely check out the ASHRAE handbook. It's got a lot of mathematical equations you should do to design a fireplace. For the purpose of this presentation, there is quite a bit of code to go through, but I'll focus primarily on what code says about mechanical draft systems. So, of course, code does say that mechanical draft systems should be listed according to UL 378, the standard for draft equipment, and installed in accordance with both the appliance and mechanical draft systems manufacturer's installation instructions. If there's anything code wants you to know, it's follow the instructions. If I had $1 every time that code told me to follow the instructions, I would be a happy man. Also, for your gas-fired appliances, it must be interlocked. So with the actual appliance to prevent flow of gas to those main burners when the draft system is not functioning. And then also, it shouldn't terminate anywhere near people, public walkways, or it does give a lot of information about terminations. I'll touch a little bit more on that here in the next slide. And then also dampers, they should also be interlocked to your appliance as well, according to code, to prevent flow of gas to those burners when until that damper is open to a position to properly exhaust that appliance. So terminations, this code here, this is kind of what code says about terminations for when you're going through the roof. It also does talk a lot about, give a lot of other information when you're terminating through the sidewall as well. But for the purpose of this presentation, the vast majority of time we go through the roof. So we'll touch on that real quick. For your low heat appliances, they need to be at least 3 feet above the highest point where it goes to the roof, and at least 2 feet higher than any portion of the building within a 10-foot horizontal distance. Medium heat appliances, a little more, 10 feet higher than any portion of the building within 25 feet. Of course, if you have decorative shrouds, chimney caps, they should be labeled and installed in accordance with manufacturer's installation instructions. Now, when you're using a mechanical draft system, you terminate at least 3 feet above any forced air inlet, unless it's like a direct vent appliance. So basically, don't keep your flue gases away anywhere, doors, windows, anywhere they might go back into the building. NFPA 211 is very similar to NFPA 54. Of course, you do have to vent all your flue gases to the outside by code. And so mechanical draft systems, they should be listed, and it permits both forced and induced draft systems, which I'll discuss here in a couple slides. Also, when you have a mechanical draft venting system in place on a solid fuel appliance or fireplace, you're supposed to have an audible or visible warning upon failure of the draft system, which all of our controllers have. You're supposed to have a smoke detector in the room, maintained in accordance with NFPA 72. And you're supposed to have a listed carbon monoxide warning device installed in accordance with manufacturer's installation instructions, of course, which we do offer. And of course, NFPA 211 also says on your solid fuel appliances that they do need to be listed to UL 378 as well. They cannot cause any flue blockages, and of course, must be installed in accordance with the manufacturer's installation instructions, and also size to maintain the sufficient draft in the range specified by the manufacturer of the appliance. Solid fuel terminations when you're going through the roof. All vents should terminate above the roof surface. Vents installed with mechanical exhausters should terminate not less than 12 inches above the highest point where they pass through the roof surface. It also says you do not have to comply with that if basically you meet all these other things that basically tell you to not terminate anywhere near people, where people might be, or doors or building intakes, windows, anywhere where flue gases might go back into the building. Also says forced draft systems, they need to be airtight and not leak at any portion of the system that's under positive pressure. I'll talk a little bit about that here in just a slide or two. So the ASHRAE equations, they offer a lot of equations to help you estimate flow. You have to calculate flow resistance, you calculate K values to determine your pressure loss, and calculate your theoretical draft and drive the available draft. It's a lot of complicated math, and then you have to make adjustments and repeat until it's negative. Oh, and make sure you didn't make any mistakes. So it's the ASHRAE equation is very much the science part of venting. It basically says that mass flow of flue gas in a vertical pipe is a function of heat release regulated by chimney area, height, and system pressure loss. But it doesn't consider a lot of things. It doesn't consider your location or crosswinds, or it assumes that everything is constant. All your heat input, your supply air, everything is constant. You have a straight chimney. So, but in reality, we know that all those things are constantly changing. Draft is constantly changing. So even after you do all this math, all you have is a starting point, which is kind of where the art of venting comes in, which is, using common sense and experience to understand and identify these potential draft problems you might have. Or you can buy a mechanical draft system and not have to worry about all the math. So, like I said, installing a mechanical draft control system is usually the most effective and least expensive option to fix most of these problems. And most of these modern fires require it. This first fire here on the left, there's no way that if that's an indoor fireplace, there's no way that would draft properly, naturally without a mechanical draft system, without spilling flue gases into the room. So a lot of these modern fireplaces, they require mechanical draft inducers. Some of the advantages of mechanical venting, they're not sensitive to all the same issues as natural vented systems. They're a lot safer because they are listed to UL standards, and they pull all the dangerous flue gases out of your house and keep your fireplace constantly drafting properly at every single point in that fire. So you always have sufficient and proper draft. A lot of times it'll also increase your burn efficiency, with these variable speed fans. And then you have forced draft fans and induced draft fans. So induced draft is when you're pulling. It's a lot of times you have a termination fan, you're pulling air through the system. And forced draft is a lot of times when you have an inline fan and you're pushing air through the system. So the problem with forced draft is when you're pushing air through the system, that part of that system, that's downstream of that fan is under a positive pressure. So by code, that has to be airtight, and you have to use special types of chimneys because you can't have any leakages under that positive pressure section, because the flue gases, carbon monoxide, can leak out through those cracks in the chimney if it is under positive pressure. So we do always recommend using induced draft systems because it keeps the entire system under a negative pressure. And they adapt to and they overcome all these constant changes in draft. So this is our RSD fan. It is, of course, listed to UL 378, up to 1,000 degrees continuous, 1,400 abnormal. But we did go above and beyond that. It also is listed to UL 705 and UL 762. So this fan can also be used to exhaust restaurant appliances like pizza ovens, things like that, coffee roasters. It can be used for your gas or solid fuel fireplaces, gas or solid fuel cooking appliances. It can also be used for your non-condensing domestic heating appliances. It is a 316L stainless steel construction, impeller and housing. We've got 3 sizes up to 2100 CFM. It also has a little clamp here that opens very easily for a very easy cleaning. And maintenance access if you need to clean the impeller or clean out the chimney. It actually holds the fan itself, so you can use both hands to clean out the chimney. It's a little picture of it, and it also uses a variable speed motor, which is really important when you are using installing a mechanical draft system, to always use one with a variable speed motor, because they can be adjusted to meet the changing conditions of the draft. As that fire heats up and gets going and starts drafting properly, you can turn the fan down so it's not overdrafting. So variable speed fans are the most efficient option for mechanical draft system, and they actually can, if used properly, achieve the holy grail of perfect draft. Also, it's also very important to use a stainless steel fan when you're looking at mechanical draft systems. There are a lot of cast aluminum fans out there, and in the case of a chimney fire, chimney burnout, it'll actually melt that cast aluminum fan, which is what you're looking at in the first picture on the left. It may not look like a fan, but that is a melted fan that melted completely, fell down completely through the chimney in the event of a chimney fire. Ours, we've basically lit this thing on fire to get the many times tested it up to 1,000 degrees, sprayed it with grease, lit it on fire to get the 762 rating, and it's maintained structural integrity. It's a great fan. It was actually designed so that you can in Europe, so that you can turn it off once your flue gets hot and your chimney starts drafting. However, in the U.S., NFPA 211, they're not going to like that. They say to keep your fan running. So you can just turn it down so that once it starts drafting, so that it's just barely going. So mechanical dampers. So what does code say about mechanical dampers? First off, the NFPA 54 says you can't have manual dampers in the connectors, and of course, all your automatic mechanical dampers, they need to be listed. NFPA 211 says very much the same thing. But it does permit manual dampers sometimes. They can be installed in chimney connectors of hand-fired solid fuel burning appliances, provided that they don't obstruct more than 80% of the connector's area. And of course, they should be listed and, of course, installed in accordance with the manufacturer's installation instructions. These are our GFD mechanical dampers, so gas flue dampers. They are, of course, listed to UL 378. The standard model is listed up to 550 degrees continuous, but there is an optional high temp version up to 1,000 degrees continuous. So basically, why install a mechanical damper? Well, it prevents conditioned air from escaping through the room of your off appliances or fireplaces. Also prevents backdraft down the chimney when that fireplace or appliance is off. So it improves the efficiency of the air in your house. We have these up to 20-inch inner diameter. They do come with fast-acting actuators, the enclosure, they are listed to be installed indoors or outdoors. And it also includes an optional fan adapter too, so that you can mount the fan right there on top of the damper. You don't need to deal with separate adapter and separate parts. These are the main controllers we use for the hearth market. The FSC is a simple rheostat controller that we use for mainly pizza ovens. But typically for fireplaces, and for hearth, we're typically using the MUC, the multi-use controller, because it meets all those codes we talked about. It has an audible or visible alarm if the draft system fails. It can also interlock with the appliance, as well as an external device like a carbon monoxide detector, and it can operate your mechanical damper as well. And then we also offer an H100, which is our premium hearth controller. It's a constant speed pressure modulating fan speed controller that automatically modulates that, adjust that fan speed to maintain a constant negative pressure, whatever you set your set point at in that system as that draft is changing. So it works with a bidirectional pressure transducer. It actually senses the pressure anywhere between positive 1 inch and negative 1 inch. Also interlocks with one appliance and one external device. It can operate your damper, and it can also operate an optional supply air fan. So we also use these systems for a lot of other applications other than just hearth. So we use them for ovens too. We do a lot of pizza ovens. We do bakeries, bread ovens, whether they're solid fuel ovens or gas ovens. We can vent them. We also do we've done a lot of coffee roasters. One of the key things here when you're exhausting a cooking appliance, like an oven, is that they have to upblast by code. The fan has to discharge away from the building, whether you're going out the sidewall or the roof. It has to discharge away from the building. We've also done this for breweries. We even sold one to a well-known rocket manufacturer who's been in the news a lot lately for a kiln that they use to manufacture rocket ship parts. So there are a lot of other applications that this fan is really great for. And then now what do we do about overdrafting? So, draft inducers, they only create additional drafts. So if you're overdrafting, the draft inducer is probably not going to help you much. So as we know, draft in your system is constantly changing depending on a number of different factors, which we talked about. So these little barometric draft regulators, also known as barometric dampers, they dilute the flue with excess cool air to reduce overdrafting. They automatically react to external conditions to maintain a steady pressure and draft inside the flue gas system. They react according to the pressure difference in the room and in the flue gas system, and the setting on the control weight. So as soon as the draft exceeds the set value, the damper opens partially to let in excess cool air. And it steadies your combustion. It automatically adjusts to all those changes in draft. So steady draft equals steady combustion, thus increasing efficiency and saving money. Very simple and effective. So what does code say about barometric dampers? Pretty much NFPA 54 and 211 agree here again. They say they shall be permitted, and they also should be installed in the same room as the appliance that they're being used, and of course follow the manufacturer's installation instructions. And it also gives us kind of a few options here, different ways that they should be installed and ways that they should not be installed, places that they shouldn't be. So these are our ZUK barometric dampers, barometric draft regulators. They are listed to UL 378, standard for draft equipment. We have the same listing in Canada as well. They're made of 304L stainless steel, so they are you can use them for in high heat situations with a brass control weight. Just adjusting that control weight can basically controls when that damper door opens and closes. So you can use them for solid, liquid, or gas fuel systems. On your gas systems, you're supposed to have a relief mechanism in there. So there is an optional integrated relief mechanism in the ZUK models of the barometric dampers for your gas-fired appliances. And they test these. They've tested these extensively. These things, they do not require hardly any maintenance. They do not break, and they pay for themselves. And they've done a lot of research over in Germany on these. This is actually an independent study by the Fraunhofer Institute, and this is kind of the results of their study they did with a draft regulator and without one. And to summarize, what they found is it increased the combustion efficiency by up to 21% and reduced the fuel consumption by up to 45%. The draft regulators, they can reduce your chimney draft by up to 83%. They can also give you up to 45% longer burn time with the same amount of fuel. And they also reduce your emissions too. So it's good for the environment. And then one of the other applications we use these systems on is to vent your domestic appliances. We use a little different controller here. This is the K150 controller. It is a constant pressure controller and does work with that bidirectional pressure transducer that I talked about, but it actually can interlock with up to 2 appliances. There is quite a bit more code on venting domestic appliances, especially when you're common venting them. Code does give us some different options. This is just one of the common options we see when we're common venting 2 appliances. Like if you have a little domestic water heater and a domestic furnace and you're common venting them, this is one of the layouts, but code does offer, it does tell you, how you can lay out the system and how you can't. But since we're focusing on hearth, I won't get too much into it. And then of course we do offer the optional dampers as well for the system. So lastly, I'd like to talk a little bit about EPA Step 2, which is kind of a recent change in the industry. Went into effect May 15th, actually, of this year. And it affects the new manufacture and sales of your residential wood heaters. So residential wood heaters includes your wood and pellet fired stoves, your wood and pellet fired forced air furnaces, and your wood and pellet boilers. What it does not include your fireplaces or masonry style heaters. It doesn't include outdoor fireplaces, ovens, barbecues, chimeneas. It doesn't include any gas, oil, or coal-fired appliances, and it also doesn't include your existing wood heaters. If you have an existing wood stove in your house, you don't have to trash it. You can still use it. The other thing it does, it also establishes some minimum requirements for the pellets themselves, what they can be made out of, certain content requirements. Some of those were removed in March, but some of them remain. But this EPA Step 2 has caused a lot of unsold inventory of these wooden pellet boilers as well as wooden pellet stoves. So originally, the manufacturers and the retailers for these stoves, they proposed an amendment to extend it by 2 years to May 2022. But EPA came back and said, no, you guys have had 5 years to figure this out. Like and turned them down and said, no, you've got until May of this year. And now, because the pandemic, they proposed an extension to extend sales until November 30th of this year. So we'll see what EPA comes back and says. They have not ruled on that yet. So what does EPA Step 2 say about your wood stoves and pellet stoves? Under Step 1 in 2015, the requirement was 4.5 grams of emissions per hour. And now under Step 2, they've dropped that to 2 grams of emissions per hour, or 2.5 grams if you're testing with cordwood. For your wood burning and forced air furnaces, the emissions limit was 0.93 pounds of particulate matter per million, but now that limit has dropped way down to 0.15 pounds of particulate matter per million BTU. And then for your hydronic heaters, your wooden pellet fired boilers, the limit was 0.3 pounds per million BTU, and now that limit is only 1/10 of a pound per million BTU of emissions. Or 0.15 pounds if you're testing with cordwood. So there is a new product that that recently came out in Germany. The Smoke Magnet Electrostatic Precipitator. Basically, this little product here is very effective at separating your fine and ultrafine dust particles out of the flue. It's about 90% effective. The way it works is there's a little electrode in there. This is kind of a cutaway picture. There's an electrode in there that charges these particles and forces them to the outside of the housing, and you can knock them down and collect them in that little collection box at the bottom. So it's real easy, very easy to clean. They can be installed indoors, outdoors, horizontally, vertically, and they will not ever block your flue. So right now we're currently testing a 120 volt version and still working on our listing. The current pandemic has put a few delays on that process, but we hope to get this released in the U.S. Very soon. So thank you for attending. That's my presentation. I am going to stick around for a little bit and answer some questions if anyone has any questions. If you would like to email me, or feel free to give me a call. This is my email. If I'm not available for any reason, you can reach out to our engineering, our RM engineering. And then, of course, please check out our website at www.kw-usa.com. Thank you very much.